All right, to continue with part 2. The reason why I have to do that, for those people that didn't pay attention the first couple times, is because I cannot have a video over 15 minutes. YouTube doesn't allow me to do that yet. After I get an X amount of videos, which I don't know how much is, they will let me do longer videos. But anyway, so I have to break it into 2 parts. So we just got done talking about the within and between. Within includes the point given, and between excludes the point given. All right, another example is a negative 2x plus 7 less than or equal to 13, or 5x plus 12 is greater than 37. So over here on the left one first, I'm going to subtract 7 from both sides. When I do that, that's a negative 2x is less than or equal to 6. I then divide both sides by negative 2. Remember, the inequality reverses, so I get x is greater than or equal to a negative 3. On the next problem, I have to subtract 12. So we have 5x is greater than, when I subtract 12, it's 25. Divide both sides by 5, and I get x is greater than 5. Now, remember, the graph is the solution. Well, first of all, we have to graph it to see what our solution is, and then it is the union of the graphs. So we have a negative 3, and that's a closed circle, and x is greater than that. And then at 5, I have an open circle, and x is greater than that. So what is our solution? They're both pointing to the right. Okay, well, even though we talk about here x being greater than 5, 4 is still the solution to the two compound inequalities. So our answer here is x bar x greater than or equal to a negative 3. That is your answer. Okay, what are the solutions to the given inequalities, the given situations with the or, the compound inequality with the or? I only need one part to be true, and the negative greater than or equal to a negative 3 includes more points than the greater than 5. It includes all of the points that are a solution. So that is the solution, is that one inequality. So you try this next problem. A plus 1 is less than 4, or a minus 1 is greater than or equal to 3. So subtract 1. So a is less than 3, or, and I'm going to add 1. So I get a is greater than or equal to 3. I'm going to graph, and it says I obviously did something wrong. When I add 1, for all those people who are raising their hand telling me I'm wrong, this is adding 1, so this is 4. Okay, so a is less than 3. So at 3, I have an open circle, arrow to the left. At 4, I have a closed circle, and it's arrow to the right. Remember, the solution set is the union of those two. So our solution set is all values of a such that we get a is, let's do it this way. A is less than 3, or a is greater than or equal to 4. So a needs to be less than 3. A needs to be greater than or equal to 4. That's one way of writing it. Another way of writing it, a bar, and then A is less than 3, or A is greater than or equal to 4. Actually, I like that way better. Um, anyways, so that way we know that it is disjointed. There are two separate scenarios in that problem. All right, it's not the same as the end where they point together at each other. The next problem you're going to do on your own, and then check to see if you have right, is x less than or equal to 9, or 2 plus 4x is less than 10. So the first problem, done. Second part, subtract 2 from both sides. So I have 4x is less than 8 divided by 4. X is less than 2. Graphing x is less than 2, open circle, less than, and x is less than or equal to 9. Notice it's going to go that way. It's going to overlap the whole x less than 2 one. So your solution set is just going to be x for all values of x such that x is less than or equal to 9. All right. Good luck on your assignment. Thank you. Remember, just do the evens.